Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing refraction of light, paper 3 for core candidates, and we will start by the KWL chart. You can find KWL chart if you join the Telegram channel. You can find all documents and mark schemes. You have to write down what do you know about refraction, what you want to know, and at the end what you learned. If you would like to share your KWL chart and follow-up sheet, you can follow the Instagram account. Okay, let's start by question number 1. Question number 1, we have a light ray is traveling from water to air, and we have here 3 light rays, and we have important information about critical angle. Critical angle for water and air boundary is 48. This is very important because we said earlier in paper 1 that you have to compare critical angle and angle of incidence. We have 3 options. It could be smaller than, or equal to, or greater than. Okay, according to the case you will answer how the light ray will behave. Okay, so number 1, let's revise what we mean by critical angle. What's meant by critical angle? You have to state complete definition, complete sentence, use scientific terminology, correct scientific term. Okay, so what's meant by critical angle? Let's write the definition. Critical angle is the angle of incidence okay in the optically dense medium corresponds to an angle of refraction 90 degrees. The location of this angle, 90 degrees angle of refraction, will be in the less dense medium. Okay, to make it more complete definition, you can write that beyond this angle the ray is totally internal reflected. Okay, let's now continue what happens. Use your ruler to draw the approximate path for the rays. Okay, we will use the ruler to draw how the ray will behave. When the angle of incidence is 40, it means 40 is less than 42. Okay, sorry, 48. So it means the ray will be refracted in air away from the normal. So angle of incidence here is less than the critical, so the ray will be refracted in air away from the normal. Okay, so this will be the refracted ray. And in this case, don't forget to draw the weak reflected ray, because we said partially reflected, partially refracted. Okay, so by same angle of incidence 40, you will draw the weak reflected ray. So here we have weak reflected light ray, and you have here refracted light ray. Okay, what happens when the critical angle is the angle of incidence is 50, which is greater than the critical? So here 50 is greater than 48. What happens? What happens here? The ray will be totally internal reflected by the same angle of incidence. It will obey the law of reflection. Angle of incidence is equal to angle of reflection. So the ray will be totally internal reflected in this case, and this will be 50. Okay, so this will be the answer for question 1. So you, on the figure, you will draw the path of the light rays when they reach the surface at point A and at point B. Is it clear? Okay, let's move to question 2. In question 2, you have here semicircular glass block, and the ray of light change its direction as it travels into the block. Refraction takes place. State the name which is given to this change of direction. Okay, the name of this, don't write bending, because bending, it's not a scientific term. Okay, use scientific terminology. So here you have to write refraction. The name of this is refraction. Okay, state the name. We are done with this. Inside the block now, the ray meets the flat surface of the block at an angle greater than the critical angle. But here it's mentioned that it meets the curved surface at 90, here, 90, which means angle of incidence is equal to 0, angle of refraction is equal to 0, which means it will continue in the same path without any change in direction. Okay, and I told you before that this point, the center of the semicircular glass block, which means this line is a radius. So which means if you draw a tangent here, it will be at right angle to this line will be at right angle to the tangent at this point. Okay, so back to our question. So you have to draw normal at the boundary between air and glass at the surface, the flat surface of the semicircular glass block. Okay, this angle is greater than the critical. It's mentioned here that at an angle greater than the critical, so angle I here is greater than the critical angle. What will happen to the light ray? It will be totally internal reflected by the same angle of incidence. So it will be totally internal reflected. This angle should be equal to this one. Okay, so the answer for this one is very simple, but let's, as we are done, complete the path of the ray of this red light. Okay, let me tell you more about this case. Here there is no change in direction when you find angle of incidence and angle of refraction is equal to 0, but there is no change in direction and frequency, but there is only change in speed and wavelength.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor.